Welcome to Future Energy. Before we get started, I'll just take care of a couple of housekeeping details. First, the emergency exits, if you need to use them, are on the far side, both sides of the room. And secondly, the Twitter hashtag is Future Energy. That's #Future Energy, which you should see on the bottom of most of our slides today. So as people are filtering in, my name is Graham Lawlor, and I am the founder of Ultralight Startups. We host startup pitch events, much like the one that you will see very shortly. We do this in a number of industries. We've hosted over 100 pitch events, just like the one that you'll see tonight, many in energy and clean tech, and also other industries as well. New York, Boston, Silicon Valley, and right here at the ARPA-E Summit. So thank you very much. This is the agenda for the Future Energy Pitch event. So we will be introducing our esteemed panel in a moment. You'll see 7 startups, early stage energy technology startups, present their idea and their business on stage, and the panel will give some feedback. At the end of all 7 presentations, you will be voting, and you'll be voting both on your favorite startups and on your favorite panelist. So keep that in mind as you listen to the presentations. At the end of the audience voting, we will announce the results in real time right up here on stage. We'll be showing who you all voted for as your favorites. And just to give you a little bit of background on the companies, so 150 early stage energy technology companies applied to present here. 7 of those were selected by our selection committee, so it's about 5%. They're all early stage, so they've raised fairly little venture capital or no venture capital at all. We tried to get a cross-section of technologies, so not everything in one technology sector, but a cross-section. And 3 of these companies are ARPA-E awardees, and they're noted in your program. I hope everybody picked up a program on your way in. So the first 3 companies presenting today are ARPA-E awardees. The remaining 4 are not. And all 7 of them received some coaching from our pitch coach. So I will start off by introducing our panel here. So to my immediate left is Colleen Calhoun, who is with GE Energy Ventures. So Colleen, you want to tell us a little bit about GE Energy Ventures and your most recent clean tech investment and why you're excited about it?
Sure, I'd be happy to. So thank you for the opportunity. GE Energy Ventures invests across a number of platforms: healthcare, software, advanced manufacturing, and energy. I lead up the energy team. We have a fairly robust portfolio. We've been active in this space since about 2006. And we focus in 3 primary areas: power, distributed power mostly, oil and gas, and lighting and energy efficiency. The last investment we made was in the 4th quarter of last year. It was for a company called Quantera Energy, which is based in Pittsburgh. And what was very interesting about the Quantera investment for us, it's a data and analytics company, and they're very focused on helping both end users of electricity as well as producers of electricity either reduce their energy cost if you're a user of electricity, or maximize your revenues if you're a power plant, by using data and analytics and analyzing what the day-ahead market looks like. So we made a fairly good investment in that company, and we're excited to see how we can connect our end-user customers with their technologies.
Fantastic. Thank you, Colleen. So next up, we have Cody Nystrom, who is a managing director with SJF Ventures.
Hi, yep, Cody Nystrom, SJF Ventures, and they just told me when we got back there that you guys get the opportunity to vote on us, so I feel like I need to do like a song and dance now, but we'll try to, I guess, keep it lively. SJF is headquartered in Durham, North Carolina. We have an office in New York and San Francisco. We invest in high-growth, positive impact companies in the fields of energy and environment, health and wellness, and education. Most are software and services and technology, scaling rapidly, usually raising less than $15 million over the life of the investment, so tend to be a little bit more capital efficient, except as it comes to some of our clean tech investments, which includes our most recent one in a company called Nextracker, which is a single access tracking system for utility scale solar PV systems, scaling rapidly in the United States and throughout the rest of the world. And I'll do another shameless plug, even though I'm over my allotted time, for another clean tech company in our portfolio, Versify Solutions, because it's very similar to Quantera, where it looks at the marrying up of day-ahead market wholesale data, but it's selling to power plant systems, so allowing operators and plant managers at the actual power plant to be able to sell and optimize into RTOs and wholesale markets.
Fantastic. Thanks, Cody. So next up is Willem Rensink with Shell GameChanger.
Yeah, so my name is Willem Rensink with Shell GameChanger based in Houston, Texas. And the Shell GameChanger program is really the front end of innovation for Shell. So we invest in a collaborative way in disruptive energy solutions that we try to link up with the Shell businesses. Then we also collaborate with our Shell Technology Ventures group as that technology matures. So we have a broad portfolio all over the value chain of Shell, and part of our mandate is also to have future energy technologies that we try to link up with our future energy group and eventually our business development in that space. And as we cover all the Shell technologies, one recent investment that we've done of a project we've started, it's actually been with the National Lab on a novel way to design catalysts for improved natural gas conversion to chemicals.
Fantastic. Thank you, Willem. So Zack Schildhorn from Lux Capital.
I'm Zack. I'm with Lux Capital. We're a venture firm with offices in New York and Menlo Park, focused on transformative technology companies with the potential to change the world. We have a little over $500 million under management, and our investments range from companies doing everything from surgical robotics to 3D printing to launching satellites. And while we don't have a specific mandate to invest in energy only, one of our most successful investments of all time is in the energy world, a company called Kurion that was founded to solve problems related to nuclear waste cleanup and has played and continues to play a very significant ongoing role at the Fukushima power plant in Japan. Our most recent energy investment is a company called Gridco Systems, based up in the Boston area. And why we're so excited about that company is really a combination of two things. One, a really capable founding entrepreneur who previously founded a very large company. And two, a really big idea, which is around really redefining the distribution power grid and taking really highly powerful solid-state electronics and bringing them to the distribution power grid to enable the routing of electrons similar to how we route bits on the internet.
Fantastic. Thanks, Zack. So here's the format of each pitch. Each presenter is going to have 3 minutes to make his pitch. He's going to stand up on stage presenting to you all and to the panel. Then we have 3 minutes of Q&A with the panel, so the panel can jump in at any point in time and ask questions. And then we have 3 minutes of advice. So this is when we'll call on each panelist individually and say, what would you do if you were this person? What would you do if you were this company? First thing you would do tomorrow morning. And so use all of that in your judgment on your favorite panelist. And the audience voting, so at the end of all 7 pitches, you all will be voting based on the system that is referenced in your program guide. We'd like to thank some of our partners that we partner with in this voting process. So TechFlow, which is a New York City-based consultancy assisting clean tech commercialization companies. Surge Accelerator in Houston, Agrion, which is an organization of corporate sustainability officers, Clean Tech Open, and Acre, which is an incubator based in New York City. So thank you to all those partner organizations. And finally, I should thank Shell Technology Ventures, which we'll be hearing from later, Shell GameChanger, and ARPA-E for having us here. This is our third year at the ARPA-E Summit, so thank you very much for having us again. And with that, our first presenter is Daniel Baer of Slips Technologies. So come on up, Daniel. You have 3 minutes.
Good evening. I'm Daniel Baer, CEO of Slips Technologies. I think our company tagline kind of sums it all up. Nothing sticks to slips. Not even geckos can hold on to our incredibly slippery and highly repellent surfaces. We have a number of approaches to make a solid surface, the solid surface of any material, become highly repellent to virtually any substance. And when I say any material, I am talking about ceramics, metals, plastics, glass. And when I say any substance, I mean not just water, but oil, blood, biofilms, you name it. And we do this by immobilizing a thin film of liquid lubricant on the solid surface. And that makes the surface become extremely slippery and therefore extremely repellent. And this trick of immobilizing a liquid on a solid surface was invented at Harvard University by Joanna Eisenberg's group. They figured out how to do this, and as a result, they won many awards and opened a new field in material science. I'm going to give you a conceptual model of how this lubricant is immobilized on the surface. Imagine a very scratched up ice rink. Out comes the Zamboni machine, puts a very thin layer of water on the surface. The water is immobilized in this case because it's frozen, but you get the idea. You get a very thin, very slippery film. And what we're ultimately solving is we're solving sticky problems for industry. So a lot of applications in lots of different industries have a problem where substances stick to the products or stick to their materials, and that creates havoc, or in some cases might cost a lot of energy. And we are basically solving those problems for a lot of industry partners. And as a challenge for our company, one of the biggest challenges is figuring out which companies to work with and which applications to go after. Next slide. Our customer prospects and our partners are varied and many. You can see a bunch of them listed up here. I'm not going to go into the details. But as I said, the challenge is now figuring out, we have incoming calls almost on a daily basis with people wanting to use slips to solve their sticky problems. So we have a number of applications that we're going after. We expect our first slips-enabled product to be in the market in 2016. We have several joint development agreements in process, and so we're poised to grow very quickly. Again, I'm Daniel Baer. I'm the CEO of Slips Technologies. I have several dozen startups under my belt, either as an entrepreneur or as venture investor or as technology transfer professional. And I want you to keep Slips on your radar.
Fantastic. Thanks, Daniel. So, questions for Daniel? Anyone jump in?
I was wondering if you could describe a bit more about what a customer problem is. I understand the slippiness, but if you could describe that a little bit more, and also how you go about valuing that problem.
Right. I'll give you a couple of really quick examples that also have a lot of value. Marine fouling on ships ends up costing the shipping industry billions of dollars in extra fuel costs because of the drag that's caused by marine fouling on the hull. So that's an example. Another example would be a container that has a high-value chemical or a chemical that has some environmental challenges. You pour that chemical out of the container, you don't want any of that chemical to be in that container because that could require rinsing, that means energy costs, et cetera. You want all of that to come out of the container. So that's another example. I don't know if I answered your question about the value. How you value this depends on the situation, but.
If you had to pick one application area of the many that are out there to go after really hard, right, which one would it be and why?
If I had to pick, we play this game at the company occasionally, gun to your head, pick one. And unfortunately, the answer is not just one, but if I had to pick one right now, I would pick the containers that have high value contents, because it's something that we technically are able to do very quickly and has a lot of multiple impact on industry and the environment.
The idea, a barrel of crude oil, surface covered with slips, and every single drop comes out?
Yeah, or imagine a container of motor oil. Every single drop comes out, or a container of a pesticide.
So what's the what's the cost basis of making the film? Do you make it as a chemical? Do you make it as a film? Or how is it applied? And sort of what's the cost of the material itself?
The cost is actually minimal. So making slips involves essentially preparing the surface to be receptive, shall we say, to be a sponge for the lubricant. And that can be done with processes that are very common. No real major cost involved in that. And the lubricants themselves are very, very thin, and there's a number of lubricants we can use. which of course have different costs. It depends on the situation. So the overall cost ends up being, fractions of a penny per square meter, let's say, or something like that.
What does the application process look like, and what's the curing time?
It depends on the situation, but in some cases it can be sprayed on, it can be dipped in, there's a number of ways to do this. So the actual time to actually create the surface is varied. And one of the products we're thinking of making, back to your question, I guess, is self-adhesive disposable films. Let's say imagine face shields that have our coating on them, so when stuff splashes on, it just drips off. And so in that case, the films would be all ready to go. Okay. They'd be pre-made, if you will.
And what's the longevity? What's the longevity of the film that you've been able to establish so far?
That's one of the first questions we always get, and it depends on the application. So it turns out for applications where slips is submerged, for example, it's quite long. In other applications, the duration is limited, but if it's a disposable, we don't care.
Okay, thanks for the questions. So now is the time for audience advice. So we'll start with you, Colleen. What's the first thing you'd do tomorrow morning if you were Daniel?
I think the first thing I would do is hone in, as I think you've heard us ask the questions on a specific customer segment, and then describe in more detail what the value proposition is for them, so you can value a sale.
Yeah, you'll probably hear similar feedback, but I think I'd go out and get an intern, and I'd have them size up all the market opportunities that you're looking at and get really specific on what exactly the product market fit is for this application, the best one that you want to go after today.
Well, I think you're doing a good job. I think you understand the problem to find the application, but I'm just wondering whether you can scale up the testing, or whether somebody else can do some of the testing on how you can make the product available. I think that, I think you heard a little bit in the Q&A. So how do you sell this? Is it the coating? Is it the lubricant? What's the longevity? What's the material that goes into it? Is it brownfield? You can only do it new. So I think elaborating these properties and how they line up, and we can test that for you. Who can test that for you, and especially get a sense of the robustness and how long does it last, and then see what price points that you really can afford in that. Because to me it sounds like it's a little bit of a hybrid between a consumable and something you once install, and I think that you have to be able to clarify as a customer value proposition.
Two pieces of quick advice, one on the pitch and one on something I would do specifically. On the pitch, I think anytime you're talking to investors, you have to make them greedy, right? You want them to be thinking about money. So I would focus more on why the technology matters as opposed to how it works. To Colleen's question, what are the applications? How big could they be? What problems could you solve? And the second thing, from a company perspective, I would want to go fishing. And what I mean by that is I'd want to go out to the world and make everybody know about this technology and its applications, so that many customers are coming to me, and the one with deep pockets and high urgency stands above the crowd. And to do that, I don't know if you've ever seen a web series called Will It Blend? You ever seen it's for a very high-end blender, and they made this very cheesy web series called Will It Blend, where they blended all sorts of stuff, and they got millions and millions of views. I would make one called Will It Stick, and create a whole series about the amazing things that your product can do, so that everybody in the world sees your video and is telling everybody they know, and one day some huge customer knocks on your door and says, we have a big problem to spend money on.
I love it. Very concrete advice, Zack. I like it. I've seen that web series too. It's good stuff. Thank you very much, Daniel.
Thank you.
Round of applause. Okay, so next up we have Avide Zakor of Indoor Reality, another ARPA-E awardee. So Avide, you have 3 minutes.
Thank you. Good evening. My name is Avide Zakor. I'm the CEO and founder of Indoor Reality, a Berkeley startup. The product and the technology we've developed is a backpack system, as seen on the upper left. It's worn by a human operator that walks inside buildings. The backpack has a number of sensors, cameras, both visible light and infrared, and it has laser scanners on it. After a normal walkthrough inside buildings, we can generate geometry, as you see in the middle picture down here, and from there, we can use it to build energy models for buildings. So the advantages of the backpack is that it allows you to do faster, cheaper, and automated energy audits of buildings. So what pain point does it solve? Well, today's energy audits are very expensive because you've got professional engineers who charge a lot of money to go through your buildings, and usually they have either a paper and a clipboard or a tablet, and they manually record the number of lights and measure geometry. So they're expensive, and they take a long time to audit your building, so that makes it doubly expensive. And also, it's very error-prone. However, with the backpack, you wear the backpack, walk through the building, all the data is processed by proprietary software after it's been uploaded to the cloud, and the data products such as the plug loads and windows and all of those are generated automatically, and they have spatial granularity that's not achievable by manual audit. So it's faster, cheaper, and more accurate. Next slide. So the markets that we plan to address are twofold. One of them is the energy market, building energy audits, and the other one is AEC, architecture, engineering, construction. In particular, in the energy market I already talked about, in AEC we're going to focus on the construction market, where many times you need to have as-built models of construction process as it goes on, so that at the end when you're done with constructing a building you have documentation, complete documentation of it, pretty much like an indoor Google Street View, but this time it's for indoors and for the construction process. So the business model, I'm thinking of 3 phases. In phase 1, indoor reality will be a service provider itself. We do the scanning of the buildings. Phase 2, we'll have a network of authorized service providers located across the country that will do the service on our behalf. And in phase 3, we can then start selling the backpack when we're more established. We have a pilot project going on one of the buildings on UC Berkeley campus, Mulford Hall, and we think we're going to be generating revenue in 2016 by doing professional services. Who are our customers? Initially, we're going to be selling through engineering consulting companies and ESCOs, and as time goes on, we will start marketing our products and services directly to property owners, facility managers, and those people.
And that's time.
Okay.
So great, thank you very much. Questions for Avide? Anyone jump in?
So how do you compete against smart sensors, BLE, being built into walls and networks in buildings today?
Oh, they're very expensive to install. So the infrastructure cost of putting those is very difficult. And one of the things I didn't mention is that in the process of the walkthrough, we collect fingerprints for buildings. So later on, we can do real-time occupancy detection with the data that we collected ahead of time. And so that could essentially revolutionize and replace all those sensor people. So putting the sensors on is expensive, and powering them up with batteries is expensive. After 2 years, the battery dies, you have to replace it. So this is really a walkthrough inside the building, just replaces all of that.
So what's unique about the backpack? You mentioned that you got proprietary software, but what's unique about the backpack itself? Is it the type of cameras, or what do you acquire on the backpack?
I think it's the first human wearable backpack, and what's hard about it is the software that allows you to use the data that most of the sensors on the backpack are off the shelf, but processing those data in such a way that you can make accurate geometry, automatically detect all the relevant energy-related stuff. That's what's so hard about it. So really, the intellectual properties in the software and the algorithms, rather than just the sensors. Also, the configuration of the sensors is kind of important.
How much does someone pay for a typical energy audit today?
It was on the first page. It's somewhere between about 50 cents per square foot, and we think we can bring the cost down to something like 10 cents per square foot. And there's a slide that's missing, but the total available market is about 350 million per year. And that comes from how many buildings there are that are over 50,000 square feet in the US, and on average, once every 10 years, they need to be audited.
How much does a backpack cost you to put together?
At the moment, it costs about $40,000 worth of sensors, but we've done the back of the envelope calculation, and the price of the backpack actually is not directly related to the bottom line and the revenue generation, especially because we have this, essentially with one backpack, it takes 50 minutes to do a whole story where traditional audit would have taken a whole week. So the number of backpacks we need is actually quite few in order to do a lot of buildings.
So this is a pretty hot space. I mean, we're seeing a lot of startups that are going after buildings and going after the potential to reduce the energy in buildings. First Fuel, Bidgley, Plotwatt, there are a lot of them out there right now who aren't even going in the buildings. Have you looked at their business model versus yours, and do you have a reaction to your value proposition versus doing it remotely?
Yeah, I have looked at companies such as First Fuel, where they look at the utility bills, and from there they disaggregate to see which components are on. I think that we have an edge over them because you can't really determine the load, what's called the load inside the building, like the ceiling lights and the plug loads, and unless you've actually been there. Also, to have a real energy model for buildings so you can play what-if games. Like, what if I change the lights from fluorescent to LED? What if I make the windows double pane? You really need to have an energy model for the backpack, and unless you actually physically go in, you can't really do it. So this is a nice compromise between the two extremes. And one extreme, you've got people who do it remotely from the utility bills. The other extreme, you've got people with paperclip and take a week to make notes of everything. And we are kind of in between the two things. We just walk in through the building. It literally takes as much time as you and I walk and collect the data, and everything gets uploaded to the cloud, where those expensive professional engineers can remotely visualize through some sort of a Google Street View thing to figure out what's going on in the building. And of course, if you add the utility bill information, we can refine the precision of our models, of course.
So time for feedback for Avi Day.
Sure.
Cody, we'll start with you this time, just to mix things up.
Well,
if you were Avi Day, what's the first thing you would do tomorrow morning?
Yeah, we didn't get into this question, but the GPS component, the mapping component seems really compelling. I mean, the energy side is interesting, but the first thing I would do, if you're in Berkeley, go down to Google and talk to them about what they're doing in indoor mapping. I feel like there might be a way to collaborate here. It's a whole entire market that hasn't been mapped out yet, literally, and it's a great opportunity.
Thanks, Cody.
Yeah, I'm wondering whether you can put these things on a robot and sort of collaborate with iRobot, that you can actually do this automatically, because then you might be able to make it reoccurring as the robot goes. Yeah, it wasn't. I agree with Cody in thinking that this mapping might be other applications. I'm just wondering whether you can compete in that space. So be very careful if you sort of incorporate a lot of known technology, sort of make sure you stay on the edge, picking the best what's out there and finding something that's unique for you and that becomes defensible, so that you're not locked into a system that others can enter in too quickly, but keep something unique in the way you get the data or use the data.
Along those lines, first of all, I love this idea of automated mapping of indoor spaces. I think it's a really big idea, and if that's not proof enough, we've invested heavily in a company that's doing something quite similar, not focused on energy audits, but indoor mapping specifically. On the energy side, I think it's a big opportunity, and I think that you need to figure out a way to scale by trying to use as much technology that's not yours as possible. And while you say a $40,000 backpack uses a lot of off-the-shelf components and you don't need that many of them, that's still a big bill for an energy audit firm to have to pay. So how can you use simpler, cheaper technology, which continues to come out, to enable others to do this, and then have your software be the special sauce? Because from how I understand this, auto-integrating those 3D models and mapping out all the components and energy loads, that's the real difficult problem. And if you can build the software stack to do that and use anybody's hardware, I think that would be a big opportunity.
And I would just add to that, I mean, I do think this is a pretty crowded space right now. There are a lot of people going after these big buildings, the stuff that JCI and company have decided not to go after. We're seeing all sorts of different approaches. So I would definitely understand the competition right now and the different models that are being used, and carve out a very specific niche that yours makes sense in, as opposed to some of these sensor technologies or the First Fuel type approaches that we're seeing being more and more intriguing by the utilities, quite frankly.
Fantastic. Thank you, Colleen, and thank you, Avi Day.
Thank you.
So next up, we have Michael Burrs of Rensink. Thanks, Michael. You have 3 minutes.
CNET asked a question. It's 2014, why is my battery stuck in the 90s? I'm Mike Burrs, president of Rensink, a high technology battery developer. We're working with the Naval Research Institute on the development of a new type of battery. We're a phase 1 ARPA-E awardee. The what CNET was talking about was cost and performance. For example, the cost, it's 30 to 50% the cost of an electric car is the battery itself. We've developed a technology that can give you the range you want, but cut the cost of that battery by 2/3. Now, there's 3 approaches to cutting battery cost. One is to improve lithium ion. The second would be to develop exotic new chemistries. The third would be to teach an old material a new trick. The first 2 rely on exotic, very expensive materials, which make up about 70% the cost of the battery. It doesn't leave a lot of room for cost reduction. If you take zinc, the old material, it's very cheap, but it breaks down after repeated cycling. Now, several approaches have been used to make zinc rechargeable, but they're bulky and complex. The Navy took a different and unique approach to the electrode structure itself, the new trick. NZinc and the Navy have taught ordinary zinc to perform like lithium ion at a cost more like lead acid. We've taken zinc particles and reconfigured them into a zinc metal microsponge, basically breaking or cracking the holy grail of electrode design. The key is that the reaction takes place on just the surface walls of the sponge, leaving the interior of the wall intact. Thereby, we can charge and discharge over and over again without the zinc breaking down. And with zinc being non-toxic, recyclable, and locally sourced, the battery is cheap to make. Now, coupling it with different cathodes, for the first time, zinc can be used in a family of rechargeable batteries, competing with lithium ion, lead acid, and nickel metal hydride. This means it's available for markets like wearables for Apple, electric bicycles for Pedigo, electric vehicles for Tesla and GM, even whole energy building management systems for STEM. Our business model, next slide, is to license the technology to battery companies for these various applications, and then we'll sell those. They'll sell those through them. We've proven that the sponge works. Our next phase then is to prove that we can build it at rate and at cost.
10 seconds.
Thank you very much.
Dennis? Okay. Thanks, Michael. So, questions for Michael? Anyone jump in?
Can you talk about how much it's going to cost to scale this? I always enjoy when GE shows up on a slide, so it's usually because people need help scaling. But if you could give us some perspective on that.
Certainly. In terms of the investment that's required to then scale this up, the first scaling, which will be a nickel zinc battery, will take 18 months and $6 million to prove out that first application.
And that gets you to what size battery?
That'll be for a 0.5 kilowatt battery.
Okay, but to get to scale for your cost competitiveness, what size battery do you need to produce?
Right. The 0.5 kilowatt, by the way, it was sized for the largest electric vehicle market on the planet, which is electric bicycles and scooters. That's about a $6 billion market out of Asia. And we think then that that's the route that we would take for the first introduction.
So what type of battery have you built to date?
We have a nickel zinc battery under test that's under cycling right now, starting off with a button size, and we've produced our first pouch cell battery, which is the building block for the larger size batteries.
How is the cycle testing going? What's the duration of the battery? How many times can you cycle it?
Right, so far we've done it in 2 different versions, by the way. One is continuous cycling, which is well over 100 cycles, in which we've checked through scanning electron microscope the possible degradation of the cell, of which there is none. And we've also done for another application, which is the start-stop vehicle. So we've done lower depth of discharge, but pulses to simulate the start-stop vehicle requirement, and that's what we've done over several hundred cycles.
Great presentation. I think all of us have probably heard a lot of battery startups pitch us, and everyone likes to believe this time it's different. But what have you learned from other battery companies that have perhaps successfully tested and commercialized chemistry, but then subsequently failed as companies? What has that taught you?
So I will speak as an engineer. One of the major issues is the scaling up process. that you talked about. And what we're so impressed with this particular technology that the Navy has come up with and that we're licensing is the fact that the production process itself is very scalable. Because we can use a zinc emulsion, we can essentially form and cast the different shapes that we need to make them available for the different applications. So the one thing is that it is a very scalable, production-oriented, and that's one of the things we've been working with the Navy on initially, up front in the research, not waiting until the end.
Can you be profitable just in the cycle sector? Is that what you call it, the bicycle sector?
Yes, ma'am. The competition right now is there's two major batteries that are available. One is lead acid, which most people use because it's inexpensive. The other one is lithium ion, which is very difficult because it's extremely expensive for the average owner of the electric bicycle because that's their primary form of transportation. The difference is that the battery out of nickel zinc, which is the first iteration, is about half the weight, which of course is important for an electric vehicle, but it lasts twice as long as the lead acid battery.
Great.
Okay, thanks for the questions. So advice for Michael, maybe Willem, we'll start with you this time. If you were Michael, what's the first thing you would do tomorrow morning?
I would think a little bit closely of what it is you want to be. I think a licensing model where you need some scale and cost of manufacturing. So it wasn't clear to me when you talk about scaling of manufacturing, whether that means you can leverage existing infrastructure or where you still need significant investments in that infrastructure. If that's true, then I'm not sure that I understand how a licensing model works, where people can pick up the pieces and what people need to see. So if you want to license out technology, you have to have proven technology at scale. So you either have to make sure you got a real prototype for people to see and not rely on others to do that for you, or you sort of walk away from the opportunity real early and hope other people will mature it, which I think is difficult to do, seeing what other battery companies have done. So I would sharpen that up and say, can you find a beachhead market where you say these batteries, I can make them at cost and I can compete, and then say I scale it through partners. I think it's hard to scale from the beginning through those partners without having done enough work.
If I were running this company, I'd be very concerned about my funding trajectory, just given all of the death and destruction that capital in the space has seen. So I'd be thinking carefully about that, and I'd also think carefully about what I can do that nobody else can do and how I can extract value for that. And what I mean by that is you claim to have a unique asset. What could you do today where someone's willing to pay a lot more for what you have versus what is the standard? Because while I really like the idea of going after a very large market in electric bicycles, it's effectively a commoditized industry where people are using very inexpensive lead acid batteries. I wouldn't want to be competing against that. I wouldn't want to have to hit that scale or that price point starting off. That might be a worthy long-term goal, but I'd want to figure out in the near term, what's an interesting market niche or smaller industry that I could go after where I can charge a very high price for a much lower volume of product.
Good. Well, I always get excited when I hear a battery company that thinks they can be profitable with a targeted market like that for $6 million. So I think maybe even changing your pitch a little bit away from the batteries for those big companies and scaling with big companies like Shell and GE and really focusing on the market where you think you can be profitable. It's not often that we hear a battery company think that they can be profitable in the short term. So if you've got that proposition, I'd be selling it hard.
Well, I was just going to say my piece of advice was to get her card, but I guess she's telling you to go off and just be profitable. Second piece of advice would be I guess pitch yourself to electric bike, electric scooter companies as a way for them to differentiate themselves in a highly commoditized market. You potentially would offer a way to come in at a much lower price point, so help them potentially work with you in funding R&D.
Very good. Fantastic. Thank you, Cody, and thank you, Michael.
Thank you.
So next up, we have Jennifer Baird of Accio Energy. So Jennifer, you have 3 minutes. Go ahead.
Hi, I'm Jen Baird. I'm an experienced startup CEO. I took my last company global and with a 10x revenue exit. Today, what I'm most excited about is cost-competitive offshore wind power with no turbines at all. Accio Energy's product is an electro-hydrodynamics-based wind power system. Think of wind and rain combining in a thunderstorm to create lightning. Akio's design bottles that idea into an engineered structure. With no moving blades, our turbine-free solution is a game changer. Using simple automotive heritage manufacturing, we create panels that are assembled into generator systems. These manufacturable panels emit a modest amount of seawater as a mist of charged droplets. The wind blows those charged droplets away and creates a charge separation and a 200,000 volt potential that the wind works against. The wind blows those droplets to ground, and we harvest the electrons that are left behind as a high voltage direct current with onshore power conversion. Last fall, the Department of Energy issued a report that said that cost was the biggest barrier to offshore wind expansion. Our $97 per megawatt hour LCOE is less than half the Energy Information Agency's projection for offshore turbines in 2018. Our advantages include 45% lower CapEx, 40% higher capacity factor, 25% lower O&M, plus compatibility with deep water and radar. Our systems will operate on seawater, be built using high volume automotive heritage advanced manufacturing, fit in standard container trucks, be mostly assembled on shore and towed out to sea, use wave pumping to minimize energy required to operate, and actually create no heat or pollution to adversely affect the water. We've developed this technology into small-scale working prototypes, modeled it at large scale, and have created a global portfolio of issued patents. Next slide. The graph shows the unsubsidized LCOE for different types of energy generation in 2018. We are able, with 2 times the gross margins and including all costs, to cut half the cost out of an offshore wind farm, enable our customers to compete head-to-head with on-land generation. Our business model is to manufacture and sell equipment to utility-scale generators of offshore power. And we are excited today to be taking our next step, which will cost about $6 million, take about 24 months to do a subscale offshore demonstration of our technology and prove that offshore wind is ripe and ready for radical innovation. Come see us in booth 1133 so we can tell you more. Thank you.
Thanks, Jen. Questions for Jen? Anyone jump in?
What is the scale of your demo project?
So the demonstration would be 10 kilowatts.
And will that be enough to demonstrate viability at utility scale? You're going to
Should be able to demonstrate that. One of the great features of this technology is how scalable it is. We're actually making individual panels. So if you imagine a solar farm where you have, if I sell you 1 panel or 100 panels or 1,000 panels, that's how it scales. Our technology was much the same in terms of its scalability. So a small scale demonstration should be able to show an awful lot of what you need to be a utility scale installation.
So what's the energy
I was going to ask, is
density
your demo
for?
project offshore? Is it deep water?
I'm sorry.
Is your demo project deep water or is it shallow?
It's actually, that's an open question. Since the demonstration, we haven't actually got it installed yet. It could be shallow, it could be deep water. We are using wave pumping, and it's a floating system, so it can go deep water. It may make sense for the demonstration project to be closer in just for development purposes, but the ultimate vision for the technology is actually to be deep water.
Okay. Well, I'm sorry to interrupt.
So what's the energy density of a panel?
So the energy density of the panels that we get 50% off, lower LCOE, is actually 100 watts per meter squared. That is less than what you see with an offshore wind turbine. Because of the technologies that are involved, we can still cut half the cost out of the wind farm. So that's how we compare it on an LCOE basis.
And so from a cost basis, what's in your view the cost of the foundation versus actually the structure that generates the power?
That model that we have developed, and by the way, we have that in our booth. Be happy to go through it in detail. Since there's not really a foundation, because it's a floating system, it's not a huge amount of the cost is not actually the panels. It's in the power takeoff is about half of it. The lower part of the structure is pretty significant. The actual panels themselves are quite cheap to make. Think about them looking a little bit like a car radiator for manufacturing purposes. Our team has a lot of automotive heritage manufacturing capability, and that's one of the things that attracted us to this technology in the first place. We are the world's leader in this technology.
Are there any existing proofs of concept for a similar electrohydrodynamic system?
I only wish. No, we are the leading edge on this. There is one other organization worldwide that's worked on it, and they are back where we were in 2010. So we are the world's leader in this, and we've actually now got it to the point where we're ready to take it commercial. So we've actually achieved that energy density for a commercial system.
Have people looked at this and kind of passed it over in the past, or is it a new idea?
Actually, it was originally thought of theoretically back in the 60s and 70s and funded by DOE and DoD back then. We've had some DARPA funding along our path. The biggest thing that's important to understand is that the electric fields, the local electric fields, is a secret sauce that makes this profitable. Until you got really advanced 3D physics models, that hasn't been figured out. We're the one organization that has figured that out, and I'd love to go into that in more detail, but it's not that people have passed on it, they just haven't been successful doing it.
So do you just need the high humidity or the high sort of availability of water around the device that you want to go offshore, or will this work onshore as well as long as you have a high humidity environment?
It's not that we are actually emitting droplets of water from the system, so we need a fair amount of water to use, and we think that the opportunity is much greater. It's because the cost of offshore wind is so great. If you remember that graph, it's so high. That's where we see a real opportunity. We use water. Sitting on our free feedstock is really handy. But we can do it. You could do it onshore. It's just not, onshore wind has become quite cost competitive, and we don't see as big a market opportunity. And then you have to figure out what to do with the water. We don't harm it, but it's got to go somewhere.
Okay, let's go into advice. So, Zack, you're up next.
Sure. I'm always a big believer in selling the future, and I think in many ways seeing is believing. And even though you don't have a system yet, your renderings that you show, I would hire someone to show what this could really look like, because you want people to believe what's possible, and you want people to imagine that future. And the materials you present make me believe that this is very far away, whereas if you're as far as you say you are and close to demonstrations, I'd want to see a rendering and better demonstration of what it could really look like.
Good. Well, I would say the wind business is near and dear to GE's heart, so I have about 8 billion questions to ask you, but probably my biggest piece of advice, the offshore wind sector is tough. I don't need to tell you that. And the toughest part about it is getting financing for these machines. So I would say, as early as you can, start spending time with the banks and understand what the requirements are going to be in order to get these things financed, because none of the guys on your list are going to do it without debt. So that would be my advice.
Thanks, Colleen.
Yeah, similarly, I mean, I think your biggest constraint is going to be capital and getting this to scale. So as many relationships that you can build in the financing world in order to have at least some confidence in saying we build it to a 100 kV system, a 5 megawatt system. We know that we'll have the financial backing to support a 100 megawatt system. And no utility developer is going to be able to bank any sort of project without some sort of reliability around the technology. So.
Yeah, I think there's a lot of merit to sort of bringing down the cost of offshore wind, but I think offshore is such a harsh environment. And you mentioned the foundation, and yeah, it's floating, but you still need mooring, and everything adds up. It's a very, very high cost environment. It's salty, it's corrosive, you've got marine growth. And I'm just wondering whether, and then you need scale offshore because you got a tie-in cost, to bring it onshore. So that I think you're creating such a hurdle. Whereas, there might be a novelty factor in it, in sort of a smaller application of like off-grid applications where, a residential wind tower is not ideal, or maybe this works at low wind, high humidity, or if there's a lot of water. And so I look at what is the application, the smallest scale that you actually can find a customer for it before you make it like hundreds of panels offshore. because that investment hurdle is going to be so high. And then who's really willing to take that unless you have a demonstration? Even you look at the existing players in emerging offshore wind technologies, which is a lot of bringing down the cost of foundations, even those have only built like a single windmill that's sitting there for a long time before people pull the trigger on the farm. So I'd really look for a simpler project, and because you might have something real cool that solves a problem for somebody that's out there.
Thank you.
Fantastic. Thanks, Willem, and thanks, Jen. So next up, we have Anthony Diamond of Axiom Exergy. Anthony, you want to tell us about Axiom?
Hello, my name is Anthony Diamond. I'm the co-founder and CTO of Axiom Exergy. We make the refrigeration battery, an energy storage solution that helps supermarkets and refrigerated facilities substantially reduce their electricity bills. So what's life like for an average supermarket? Supermarkets are plagued by razor-thin profit margins of about 1.38% on average, and they spend a lot of money on utility bills. You ever notice how cold it is in your local supermarket? That's not the AC, that's largely leakage from these massive refrigeration systems. On top of it, supermarkets are being penalized for using energy during the peaks of the day when blended electricity prices are 5 times higher, or can be 5 times higher than during off-peak times. It's been impossible to manage the largest energy consuming system in a supermarket until now. So the refrigeration battery is a simple, non-invasive retrofit that plugs into the existing central refrigeration system just like a new display case. It's fast payback because the customers already own the most expensive components of the system. The refrigeration battery has a fail-safe design, and savings can easily be quantified and financed. In fact, the National Renewable Energy Laboratory has vetted our technical models for accuracy and completeness. So how does it work? We charge by freezing a tank of water with some common additives at night when energy is cheap, and then melt it and use it during the day to provide the refrigeration. Our novel system architecture allows us to offset both condensers and compressors, providing 4 times the savings as old systems. The refrigeration battery is a workhorse that effectively allows supermarkets to use energy storage for the first time. Next slide, please. Thank you. So what do we do? In order to maintain a laser focus as an organization, we are selling, operating, and maintaining a single version of the refrigeration battery. We offer no money down financing so our customers can save more than they spend in the first year. Moving into year 2, we'll begin to offer subscription services such as facility-wide demand response and food spoilage insurance. And we'll use our growing brand presence to sign up channel partners such as refrigeration sellers, installers, energy services companies, and refrigeration equipment manufacturers. In closing, we have a large addressable market of $8.8 billion in the US, consisting of supermarkets, refrigerated warehouses, and food processing facilities. We have our first paid pilot project scheduled with Whole Foods for delivery later this year. Our project pipeline constitutes more than $1 million in revenue over the next 18 months. We have completed a functioning prototype. Our IP strategy has been crafted by our patent attorneys, KPPB, and its defensibility has been vetted by a third-party patentability report through Thomson Reuters.
10 seconds.
Our management team combines supermarket domain experience, relevant technology expertise, and a proven ability to execute. And we recently won the Clean Tech Open, the Venture Capitalist Choice Award at this year's Clean Tech Open. Thank you very much.
Thanks, Anthony. Questions for Anthony? Anyone jump in?
How do you,
No, go ahead.
how do you get over the inherent challenge that a grocery store operator doesn't want to be a utility company?
So they don't have to do anything. We're operating and maintaining these systems. So we offer them no money down financing if that's a barrier to entry, but in cases we've seen that it's not an issue. We deliver the system and then we operate it. We have a cloud-based control monitoring system that allows us to utilize predictive adaptive charging algorithms to charge in real time and augment our system performance depending or accordingly.
So I think this is a super, super interesting space, especially with the whole question around resiliency that's coming up and how much money these grocery stores can make when they're online and everybody else is offline. So how much of the interest in this does Whole Foods have about being resilient as opposed to saving money on their electricity expense?
It's a combination of both, but the savings that we can provide really move the needle. In our initial target market, which consists of 11 states that we've identified with really favorable time of use rates or incentives, our paybacks look like 2 to 4 years. So $20,000 in utility savings has the same effect as $1.4 million in additional sales of groceries. So it moves the needle, the savings.
Can you offer them resiliency today with your system?
So that we can configure our system to do so, correct.
You can configure it?
Yeah, it just requires some minor modifications, but
That's great.
right now, yeah.
Have you validated that this technology indeed is financeable? Like that you can get the financing for the supermarket?
So my co-founder spent the last 3 years at an energy services company where he led the sales and development of a $100 million retrofit of 74 supermarkets. And he has had to bet his job on his ability to measure and verify savings. So through his connections and through his knowledge, these systems clearly appear to be financeable and bankable.
How do you interface with existing refrigeration systems?
Yeah, so if you're going to add a new display case to a refrigeration system, there are nipples or ports that you can attach to. So these systems are largely configurable. They are made out of a mismatch of different parts. So they're all made to play nice with one another. So compatibility is not an issue. We come in with minimal programming or physical modifications to the system. We operate and we just passively satisfy the set points of the system. So we don't have to make any of those.
So there's an existing compressor that's separate from each display case?
Correct. And there's a header manifold where you can connect a new case as needed to expand or decrease the capacity in the store.
How long does it take to typically do an installation?
So the installation should be doable in the course of a day. So fast installation.
Okay, time for some feedback. So Colleen, we'll come back to you to start. If you were Anthony, what's the first thing you would do tomorrow morning?
I would go as fast as I can. I think you're hitting on a really interesting segment, and there are a lot of really very innovative companies on the buying side on this sector. But like I might have mentioned in a couple pitches ago, there are a lot of people looking at this space right now. So I would go as hard as I can at a Whole Foods and then make as big of a noise as you can.
Yeah,
I think it's exciting.
Also wanted
No response? So Colleen, in terms of going as fast as he can, what's the first step in that? He goes to Whole Foods and then what?
Try to get as many Whole Foods demo projects as if you can get the person at Whole Foods to buy it, say I'll do it at 20 stores and do it perfectly for them. But if you make a lot of noise around a Whole Foods, everybody else is going to be looking over and calling you up and saying, what can you do for me?
Great, thanks Colleen. Cody, what's the first thing you would do if you were Anthony?
Yeah, I don't know if it's solvable, but I would really try to get your ROI under 2 years. And I don't know if it's, a portion or your biggest energy hog stores or, whatever square footprint would fit that potential payback period. But it seems to me that the commercial environment seems to have this, easy, quick decision, 2 year and under payback period. And over that, it becomes much more challenging.
Willem?
I would again look at your channel partners and see who can help you scale and see whether you can do that demo project as fast as possible. And I think the biggest challenge is going to be how compatible is it? And so you're saying like, well, every sort of refrigeration system in a store will work. But I think if you can find a sweet spot where it's just a little bit cheaper, just a little bit more efficient, and do sort of a quick map on who would be your most attractive customer, so you get a higher success of sales in the end, and a higher margin where you don't go to the old customer. So if you do get a little bit of segmentation, what fits, which equipment fits best, that might be a good way to scale and get more targeted channel partners than try to market to everyone that's out there.
Yeah, related to Willem's feedback, once you've proven you have a product and have optimized that product, I'd figure out how to, in a sense, virtualize the company as much as possible by optimizing for scale across your channel of installers, your manufacturing base, who can make this for you, who can install this for you, and who can do it really quickly outside of your own direct need to be in touch with customers, in stores installing, because that's going to really slow you down. You know, I'd want every HVAC professional in the country who does commercial refrigeration to be able to walk in a store, make the sale, do the installation, and you get paid.
Fantastic.
Thank
Thank you,
you.
Zach, and thanks, Anthony. Round of applause. Next up, we have Tony Lochtfeld of Amber Wave. Tony, you've got 3 minutes. Go ahead.
Thanks. So yes, I'm Tony Lochtfeld. I'm co-founder and CEO of Amber Wave, and we've developed a high-performance, flexible silicon solar cell. It's a crystalline solar cell, but it's about 90% thinner than traditional crystalline silicon solar cells. To be able to handle it, we bond it to a stainless steel carrier, thin stainless steel carrier. And that means you can flex it without cracking, you can drop it, you can walk on it. It's essentially unbreakable. It's also very very moisture tolerant compared to other options for flexible photovoltaics, such as thin film technologies. And these qualities make it really ideal for direct integration with building materials, whether it's factory integration with asphalt shingles, or with the larger steel roof panels used in commercial rooftops. And this idea of integrating with roofing materials, building integrated photovoltaics, it's been recognized as an important pathway to balance the system cost reductions for solar. All of those non-module costs, which are keeping solar installation costs relatively high. If you have a PV system that goes up with a rooftop instead of being bolted on afterwards, you simplify installation, you get rid of all of the racking and mounting hardware cost, you reduce the labor. But for this to really make a big impact and get an important share of the market, the solar cell itself has to be competitive with crystalline silicon, or show a pathway to being competitive with crystalline silicon in both cost and efficiency. In addition to being flexible and thin, so it's easy to integrate with building materials. That's the solar cell we're targeting. We believe we have that cell, and we see a pathway to up to 30% system cost reduction using this approach. Next slide. So we're going to initially be the manufacturer of flexible cells and modules. We're going to sell directly to big building materials companies. We're going to support them in integrating this into a final building integrated rooftop product, and they will be our distribution channel. And I wish I could name the people we're working with, but they prefer to keep a low profile at the moment. We're really going to look at starting with the steel rooftop market. I think they can pay a premium price. And there's another interesting premium market emerging of unrelated to rooftops, which is persistent PV-powered drones, which companies like Airbus and Facebook and Google are looking at for wireless expansion
10 seconds.
and remote sensing. So that's another way in to solve the problem of how do you scale up, basically.
Thanks, Tony.
Thanks.
Okay, round of applause. Questions for Tony? Anyone jump in?
I mean, the first question I would ask is, how do you not die? Because this is a field that is just a graveyard of companies.
How do we not die? That's a good question. The most important thing is that we, except for our proprietary wafer-related steps, the solar cell steps are established mainstream steps using established mainstream tools. So we're inventing as little as possible that's new. That's what I would say. And number two is, I think there's a lot of people out there who are still excited about the concept of BIPV, but it's never taken off because the right solar cell hasn't been available. And there's enough excitement out there that it's keeping our investors interested. The conversations with building material suppliers are keeping them interested. So that's the answer.
So is the key differentiation then lightweighting of the panel?
The key differentiation, so the lightweight portion is an important aspect because it probably adds about 1/4 of the weight to a building as a traditional rack-mounted system. So, and there is about a third to 40% of the commercial rooftop market, which is weight restricted. But the real differentiator is it's flexible, but it's as cheap, and it will be as cheap and efficient as a standard silicon solar cell at sufficient volume. So other flexible solar cell technologies are much less efficient, and they're much more expensive for reasons that I don't have time to go into.
Can you talk a little bit about your manufacturing process at scale up and where you would be manufacturing these?
So we look to do initial manufacturing ourselves in the United States at this up to the sort of 5 megawatt level at least. We think we can get to, because we think there are segments which are going to pay a premium, we envision getting to profitability at a size as small as about 5 to 10 gigawatts. Beyond that, we would expect to leverage underutilized solar cell manufacturing resources because we do use, most of our steps are established steps.
So the killer in this sector, I'll ask the different ways, how do you not die? The killer in this sector is capital costs. So
Correct.
just describe, I mean, 5 to 10 gigawatts of capacity is expensive, and what your strategy is to scale up in terms of capital.
Did I say gigawatts?
Yeah, you said
I
gigawatts.
meant megawatts.
Oh, okay, I was like.
That's a big difference.
Yeah, that's a really big difference.
So we're going to get, at our facility right now, we're going to get to 5 to 10 megawatts. We can get to profitability with, we estimate $8 million from where we are today. And the scale up longer term is where we start to look at existing manufacturing lines that are out there that are perhaps underutilized.
So you can be cost competitive at a 5 to 10 megawatt scale?
Yes, for segments of this market which are not just underserved, but basically not served right now. In particular, there are metal rooftop makers who are interested enough to pay enough of a premium over standard crystalline modules that we think we can make it work at between 5 and 10 gigawatts.
Oh, okay.
Megawatts, I'm sorry.
You're back in the megawatt.
Okay, so let's go into the advice section. Cody, I think you're up to go first. What's the first thing you would do?
The first thing I would do tomorrow is come to my house and install some PV on my rooftop, and I will blog about it and tell everyone how great it is. The next thing I would do is probably figure out if you, I mean, it sounds like you've already found some distribution partners, but installers who can prove that this is, rapidly, installing and you're really saving those costs, which is really what you're fighting against. It's a neat innovation on the technology side, but you're talking about a reduction in the balance of systems and the installation costs, which you're going to have to prove with time tests and that sort of thing.
Yeah, I mean, if I hear it pitched correctly, I think you're relying a lot on sort of a premium customer. And then it sounds like then the integration piece is something that helps, but then it takes still quite a while until you have a workable prototype on that. And then is that enough to sort of stay ahead of it? And is there a unique customer that you can't meet with the current existing solutions? Like you said, if you need a lightweight panel because you can't just support the weight and find something else, then it sounds like you're towards the aesthetics. I think that's sort of a risky market where there's a novelty factor with a very small market. Whereas if you think about it, a lightweight solar panel that is easy to install might have a bigger appeal, and then find the right partner to scale it rather than necessarily go for this niche and then have a few pretty buildings and then sort of be done.
If I were running this company, I think I'd do a big gut check tomorrow morning. And I say that in the most sincere way I can. I mean, I'm hugely passionate about the long-term benefits and appeal of photovoltaics, but I'm also a realist in recent history of startups, particularly in this space. I mean, any startup is hard, but this is a space that's been particularly tough. So I think it's going to take a real insane focus and passion to really get this to a place where you can achieve a lot of success. And so I want to make sure that I was really ready for that ride and willing to go for it and really excited about it because it'll be a tough road ahead, but I wish you the best of luck.
Thanks.
And I'll just echo, I'll steal what Zack had mentioned a couple pitches ago, but there are a couple that startups that we're familiar with that had a very similar strategy to yours and did not make it. Going after niche markets, high efficiency, lightweight, et cetera, and they couldn't get the capital that they needed even to scale up at a 5 to 10 megawatt level. So it's just, I mean, there's a lot of carnage. And so I applaud you. I think it changes the world with these types of innovations, but the capital is really, really tight in this sector.
Thank you, Colleen, and thanks, Tony.
Thanks.
So our last pitch of the evening is Callum Chisholm of Safe Cell. Callum, you have 3 minutes. Go ahead.
Thanks, Graham. All right, our current electrical grid is only about 33% efficient. That means that we waste about $80 billion worth of equivalent of natural gas every year, with the consumer, meaning you and me, and nature picking up the bill. Wide-scale adoption of small distributed power units would recover or not use most of this wasted energy. Fuel cells are the leading candidate for this distributed power unit, and that's because at the heart of a fuel cell is a device called a stack, like in the circle there, that converts the fuel electrochemically into electricity. And because this process is electrochemical, it's highly efficient and it's also long-lasting. This has been demonstrated in fuel cell products to date. However, current systems are also too expensive to be widely adopted, and that's because they fall into two categories. Either they're low-temperature technologies that operate about 80 degrees Celsius that need ultra-pure hydrogen, which dries up their fuel processing and cleanup systems, or they're high-temperature technologies that operate around 700 to 1,000 degrees Celsius that run very easily on natural gas and other commercial fuels, but simply because they operate at such high temperatures, they have very high material costs. At SafeCell, we've developed a new intermediate temperature fuel cell technology that operates around 250 degrees Celsius, or the high temperature setting of your oven at home. And at this temperature, we can operate very easily on commercial fuels like natural gas, similar to the high temperature fuel cells, but we can still use the low cost metal and polymer components that you would find in a low temperature fuel cell technology. And our product development roadmap starts with high value niche markets such as, still back on the last one, niche markets such as remote area power and portable military power. For example, this unit here is remote area power for oil and natural gas, electrification of wellhead control and monitoring systems. This unit is about 10 times more efficient than what they're currently using. It has 1/10 the installation cost and can run on on-site fuels. Overall, that reduces the total cost of ownership to the operators by about 3x. And we also have higher power options to electrify these systems further in the future, reducing their operating costs even more. Next slide, please. Our business model is to be a stack provider. That means we are beholden to our system integrator partners to build full systems so that we can sell stacks to the end customers. For that reason, we're only partnering with the best in the business, and we've got significant government funding, including an ARPA-E grant to facilitate this development. And right now, our core focus is deepening our existing partner relationships and expanding on new ones to get our technology out into the market as fast as possible, not only in the first market applications, but also in the more mature applications such as home residential.
And that's time.
Thank you.
Fantastic, Callum. So questions for Callum? Anyone jump in?
So one of the killers in this space is the life of those stacks. So do you have an estimate on the life of your stack?
So we're at about a year right now, which is enough for those initial applications.
Yeah, but they need to be more like 5 or 6 years for the economics to work. Is that right?
Are you talking about the, like, say, oil and natural gas wellhead applications or residential?
Well, I was thinking more just, I mean, when we analyze fuel cells and we look at just the cost of electricity, and you have to build in the life cycle cost of the installation.
So for the oil and natural gas, no. The answer is they have such a high pain point that we could reservice the system at about $2,000 per year and still meet their requirements over the 5 to 10 year lifetime. But that, obviously, they pay a lot for these units.
Yeah. So what the levelized cost of electricity in your assumption there is 40?
Well, no, I'm just telling you what they pay. They don't really care that much about the price of the electricity. It's more like, does the unit do something for them? It's enabling, and basically, can they turn it on in the summer and then not come back to the next summer because they don't want to touch it all winter long when it's in the middle of nowhere under a whole pile of snow. So It really, we have some other properties there that actually reduce their total cost of ownership, but that's more just they're looking at like fuel costs and stuff like that. So what you're asking more would be like a residential application. And for that, indeed, then it does need to last probably more like 10 years.
Right.
Yes, and that's why we have an ARPA-E grant. Yeah.
Okay.
So what have you built to date? What type of scale and how many?
Kilowatt size on the stack level, 1.5 if you want to be exact. And then on the system level, we've built about 50 to 100 watt units.
That's pretty good, though.
And we're developing a propane unit for the Army and a methanol unit for this remote area power unit.
How much does the portable unit weigh, and how does that compare to others?
So the portable unit for remote area power basically weighs about 25 pounds. And that should be compared to about 160 for the other thermoelectric generator that they're using. That's what I'm comparing it to. And then that 25-pound unit can basically just put on a stand. So the installation is ours, whereas a thermoelectric generator, because it's heavier and the way that it operates, they have to level the ground and put some rebar in and stuff, so it saves a lot. Our unit saves a lot on installation.
How do you plan to structure your relationships with the system providers that you're selling into?
You mean the end customers, like the...
No, not your end customers.
The system integrator partners. Well, I mean, basically, it really is a partnership. They have to believe, in the technology that we have, and I think you said a wasteland. I think fuel cells have an even longer history of destruction than solar technology. So I'm happy to say that even after more than a century of people investing in fuel cell technologies and things exploding, we are actually attracting the attention of some of the best people in the industry, and they wouldn't be looking at us if they didn't think that our technology...
What do you imagine that relationship looking like over time, though? Are they just buying components from you? Is it
Yes, they're buying stacks from us.
Okay.
Yes, however, what I'm finding is that when we're working with, there's a relationship between the stack and the system that's really intimate, so you kind of get really involved with your partner. And so you probably end up carving out niche markets that you've developed with that partner that they have some amount of control over. But that's the price you pay to kind of piggyback on all their 40, 50 years of worth of development.
I think that's all the time for questions that we have. So advice for Callum. Willem, I think you're up. So what would you do if you're Callum tomorrow morning?
Yeah, again, I think this feels like a very crowded space where you see a lot of these types of technologies. So I think articulating differentiation is important. But also I think, you have a lot of applications in mind that you're going after. And I'd look very careful in what is it that these people want to see, demonstrate it before they become a real customer of yours. And then see what is needed to serve those customers. So where can you enter and how can you tell that story? For example, the longevity might not be there. But then can you finance or can you improve on that through R&D and then get the longevity there? But really especially if you want to license out, partner, get a feel for what people want to see demonstrated and really focus on that so you have something to showcase and people start believing it.
As you do prove out the technology and grow your business, I would think about how you structure your relationships with those partners, which is why I asked that question, to help eliminate some of the dependency risk that you face, whereas a partner might be responsible for interfacing with the customer and selling your product, and that's almost entirely outside of your control. So how do you control that relationship more or have more direct contact with your customer so you can, in a sense, set your own destiny as opposed to just being beholden to the decisions of others?
I would say that it surprises me that I don't see Asia on your list. The Asians, Koreans, and the Japanese are paying a lot for fuel cells, as you probably know. So it's curious to me that that's missing in your segmentation. I think that would be an area that I would explore a bit. They have a big appetite, or appear to have a fairly big appetite, to test the new technologies. Maybe the one-year stack might be your holdback on that, but there's a lot of money in Korea and Japan for this type of technology.
Similar about money, but in the US at least, I'll speak for VCs are definitely very fatigued by the concept of fuel cells, which I'm sure you've come to appreciate. So I would keep funding it as much as you can from non-dilutive sources, project funding from DOE, DOD, other kind of project initiatives, and hopefully that kind of keeps enough cash flow in the company until the acquirer kind of sees the value of it.
Fantastic. Thank you, Cody, and thank you, Callum. Okay, so now is your chance to vote for your favorite startups and your favorite panelists. So pull out your smartphone and type in this URL.
We have to sit here for this?
You have to sit here. You have to sit here. And you have a 25% chance of winning yourself, Zach.
Yeah,
so
that's pretty good odds.
good luck to you.
They made us leave our cell phones behind there. Did you notice
No,
that?
we don't get to vote.
You should all have this URL also in your program guide if you happen to pick one up on your way in. It's uls.bz, that's like ultralightstartups.business, or perhaps Belize, depending on your perspective, ARPA-E 15. And while you are all voting, we will hear from Willem Rensink, who, in addition to being our panelist, is representing Shell GameChanger, which is the sponsor of tonight's Future Energy Pitch event. So, Willem, do you want to tell us about GameChanger again and how startups can get involved? It's actually at the bottom of the screen. Well, okay.
Okay, put it back on the voting, that's fine. We can show a little bit more about Shell GameChanger. So Shell GameChanger is a flexible funding mechanism that Shell offers to entrepreneurs that have more non-traditional, disruptive type innovations that are sometimes difficult to fund otherwise. And what we offer is a collaborative partnership model that's very flexible depending on where the technology fits with the Shell business needs and what needs to be demonstrated and what the entrepreneur or startup wants. Or we also work with universities, national labs. So we're really open to where ideas come from, as long as they have a high level of novelty and a high value proposition. And we try to create a link between that initial idea and the Shell business or a venture investment by the Shell Technology Ventures. So we can offer that initial seed demonstration that then allows that larger relationship. So our funding range is stage-gated funding anywhere between $200,000 until like $1 million. But that's sort of what we can do to bring that technology to maturity and land it somewhere in the Shell business, or we part ways if it didn't work out. And to connect with us, you can either find us in the booth at the showcase tomorrow, or you can directly go to our website, which is shell.com/gamechanger. And if you want more information, just try to find me around in the meeting. I'm going to be here tomorrow and Wednesday.
How many companies a year does GameChanger typically work with?
We get typically, so we get a rolling portfolio of between 50 and 60 projects in our overall portfolio. And so every year we make 20 to 25 investments. And typically we get about 600 applicants each year. And obviously we see a lot more of people that we select to work with.
Do they tend to be directly related to oil and gas, or are they?
We work across the whole business space of Shell. So we go from biofuels, bio-based chemicals, all the renewables, energy storage, energy integration, microgrids. So the whole gamut of future energy technologies. Again, we have a few domains there. So in the future energy space, it's a lot around offshore wind is actually one theme, green renewable energy generation. Another theme is energy integration, energy storage. And then the third one is around the hydrogen, liquid hydrogen and hydrogen value chain. Obviously linked to mobility, but also as a way to decarbonize the natural gas value chain. And in the traditional business space, it's a lot about energy, enhanced oil recovery, and now a new focus of ours is to bring down the cost of construction. So we've seen the cost of construction has come up, and so we're looking for smart building technologies and faster and smarter ways to build and automate processes.
Fantastic. Is anybody still voting? Raise your hand if you're still voting. A few people still voting. All right, Colleen, does GE have a program similar to Shell's that you can talk about how startups might get involved with?
We did not as aggressively or as large as Shell does, but we back incubators. So we work with a couple incubators on specific target areas. We do A-round investing in a limited case, but we spend time with startups, specifically connecting them to our research center. I think that's probably the best connection an early stage startup can have with GE.
At your research center.
Right,
Okay.
exactly. And there are a lot of our technologists here at the ARPA-E conference.
Great. Cody or Zack, what's the best way for startups to get in touch with you or to work with SJF or Lux Capital?
Yeah, they can just reach out. My email's on our website, and YSJF does not invest in startups. We love to build relationships with entrepreneurs in the beginning. We invest usually once companies have reached some sort of commercial traction in terms of revenue or number of customers, but would love to hear about your ideas, and we make connections where we can, and hopefully can partner once it becomes appropriate for our staging.
Email's easy. It's just Zack, Z-A-C-K, @lux.vc, if you want to email me. I think the most important thing, though, in contacting any investor, and I think this is something I've learned over time, is make sure you do something to get their attention. Be different. Tell a good story, because any investor is seeing hundreds or thousands of different companies, and they're really looking for those special entrepreneurs who are going to rise up above the crowd. And it's not just about the technology. It's not just about the idea. A lot of it comes down to the people and how they present that idea and what story they tell. So I think a lot of people, particularly with technical backgrounds and technical problems they're trying to solve, tend to gloss over that or not pay as much attention to it. But I think it's something I've learned over time is being really critically important to success.
Fantastic. Thank you, Zack. Okay, so let us refresh and show the voting results for the startups. Here we go. Axiom Exergy, Anthony Diamond, first place. Awesome. Come back on stage. And number 2, Daniel Baer of Slips, and then Avide of Indoor Reality. So come on back up on stage, the 3 of you. Congratulations to you all. And last but not least, the real big prize. Who is your favorite panelist today? Scroll down a bit. Zack Schildhorn, Lux Capital. Congratulations. Well done, Zack.
Thank you.
Awesome. And thank you all for joining us. Thanks so much for ARPA-E for having us here for our 3rd year. And we look forward to seeing you at the networking and tomorrow morning. Thanks very much.